Hi, this is Kurt from Boards 3D, and today I'm going to show you how I designed and made my GoPro ring light. Well, it's more of a rectangular light, but you'll see soon enough what I mean. I started by continuing my work in Fusion 360, using the same 3D model that I used the previous time for the GoPro adapter. And I started by designing a mock placeholder for my GoPro. I've got the GoPro Session model, which are tiny and cubical, not quite as wide as regular GoPros. I took my time trying to center everything and try to get everything in the right orientation as possible, as this would let me design in place and be as accurate and not requiring as many adjustments later on after I print. The GoPro placeholder was made by sketching a square on one of the axes and then extruding it using the extrude function. I took some measurements with a caliper, the digital caliper, and inputted them into Fusion 360. I had an idea of what I was going to end up with in my mind, but I did not have an exact way of going about it. And to me, this is one of the most favorite ways to do things. It's sort of figuring out what problems and what obstacles you have to jump over. It occurred to me later on that I should center the model for it to be symmetrical. It would allow me to, make accurate calculations. I have some cheap LEDs I bought off Amazon, and I want them to fit around in this rectangular fixture. I had in mind something like the ring light that Bob from I Like to Make Stuff made a few years back, but I did not want to go through the whole Arduino Adafruit trinket route. I wanted something a bit more simple, something to which I could just hook up a battery, connect the wires, and that's just it. When I'm doing something like this, I'm always looking for simplicity as much as possible, and being practical about it. I chamfered the edges, the corners over there, as you can see, in order to make it a bit more aesthetically pleasing and to use less materials while printing, as the corners are not really going to have a lot of strain. LEDs are pretty light, and these kinds of LEDs, given that they will not be enclosed anywhere, will not get hot enough sort of to compromise the integrity of the print. However, I needed them to be recessed slightly into the frame, so I sketched some rectangles, and after some calculations with both the calipers and the inspect tool inside Fusion 360, I drew these sketches and extruded them inwards, making a cutout or a groove in the model. When doing something like this, I prefer working in halves so as to have things symmetrical. So as you can see, I worked on one half first, then I mirrored it using the mirror tool. And at first I thought that this would be the ideal design for this bracket. However, it dawned on me later on that I will not be able to access the GoPro's lever screw thingamabob easily. In fact, I took some measurements and I discovered that it would not work as I thought it would. So I ended up cutting that part of the bracket, and it ended up working just fine. I extruded a part of the shoe, and that let me sort of fit it into the tripod itself, and without any kind of adhesive it works brilliantly. It just fits, it's just a friction fit next to the GoPro adapter, and it just goes on the tripod. I split the parts in order to allow for a better printing. It's better, sometimes it's better to just print several items rather than having one huge item. Usually large items on their own require a lot of supports. Having said that, sometimes that is the only way necessary. In this case, I try to be as conservative and economic as possible, even in the simplicity of the design. The LEDs themselves are 12 volt LEDs, and they do not require any particular, they don't even require 12 volts to function. In fact, I use a 9 volt battery on them without any kind of resistors or circuitry, and they work just fine. They're super bright, as you'll be seeing very soon in some pictures that I've taken. Nowadays I use this to record and record time lapses of the 3D prints, and therefore it requires a power supply close by. I designed a small caddy, a small pocket for that 9 volt battery. It's not high enough for it not to topple over, but then again, the 9 volt battery does not really require any particular support, as it usually doesn't move around while recording time lapses. If in the future I decide that I need to do that, it can be designed very easily, and I can add it on to my current structure. Basically, I finished this model by simply sketching and extruding most of the parts. I didn't use any particular tools, and it does not require any kind of particular know-how to do something like this. All it takes is just a little bit of curiosity, creativity, and just a healthy helping of trying it yourself. So here's the finished product. I printed this on the Prusa i3 Mark II 3D printer, the one I mentioned last time, and it's here for a very particular reason this time. It's in my room because I am currently working on the workshop. I'm upgrading it, and I have a series of videos coming up on it later on. Regarding this thing, first of all, it works magnificently. Let me show you. So it's got a holder for the 9 volt battery back here. It's got the LEDs all around the perimeter. Now, pardon the crappy job of soldering. I had never soldered before. This was my first experience soldering. I love it, by the way. So 9 volt battery goes in here, right? And then you just hook in the 9 volt adapter. I'm not going to plug it. See, it's incredibly bright. Anyway, there are a few things which I would like to add to it in the future, and maybe a Mark II version will be available soon. I'll try to put this up on Thingiverse and my mini factory for sure. Links will be in the description down below. However, some things which I would change are the following. I would try to include channels inside so that the wires themselves could be hidden inside the frame instead of outside, just to make it a bit more neat. And secondly, something which I will definitely do very quickly, or very soon rather, is that I have to install this switch. I think I'm going to mount it somewhere to the side, and where I could basically and have the 9 volt battery hooked up indefinitely, and I'll just turn it on with a flick of the switch. Thanks to my buddy Eric for supplying the switch. I was too lazy to go to the electronics shop and buy one, and he very kindly donated one. I'll be putting it to very good use very soon. So that's pretty much all there is to say about this thing. One final note is that it's printed in 3 pieces. It prints bracket itself, what I'm calling the square light or rectangular light. There's the 9 volt holder and the shoe, adapter that goes into the tripod, and basically I just glue them on with cyanoacrylate with super glue, or crazy glue, I believe they call it in the US. So that's basically it. It didn't take too long to print, a couple of hours, and it was done. The adhesive on the back of the LEDs is holding up pretty well. I didn't use anything else, except I was a bit fearful that the solder joints would break off, so I put a bit of glue on them, sort of to hold them together, but just the solder itself should do the job. So, you know, we'll see. I'll keep you updated on social media if there's any changes with regards to this. So if you like this video and would like to see more of what I do, click that like button and that subscribe button, and make sure to follow my channel, as I'll be uploading more videos in the very, very near future. Also on my social media, Facebook, Instagram, Twitter, I usually post there as well whenever I upload videos or whenever I have something to share. And that's it for today, and thank you very much for joining me. I hope that you enjoyed these videos, and just like I was inspired by the people to go there and make something like this, I hope that you too can go and do something as well. And remember, everyone's a maker.